As we've been saying in the previous videos on hypothesis testing, our null hypothesis could be true or it could be false. In addition, the result of the hypothesis test could be that we reject the null hypothesis, or we could decide to not reject the null hypothesis. The rejection of the null hypothesis when it is in fact true is a type 1 error, and is a result we want to avoid. To not reject a null hypothesis that is in fact false is a type 2 error. This is a subject for a more advanced statistics course and will not be discussed in this video. In this example, we will presume that we have a population with a mean of 55. Our null hypothesis will therefore be that the population mean equals 55. Now let's suppose that we've taken a sample of size 15, making the degrees of freedom equal to 14. Remember that the degrees of freedom is always one less than the sample size. The sample mean we determine to be 57.25, and the standard deviation of the sample is equal to 6. We now decide that because the sample mean is greater than the population mean of 55, we will state our alternate hypothesis as the population mean is greater than 55. Now we need to choose a level of significance. Remember, this represents the probability of making a type 1 error. What we are saying here is that the data we retrieve from the sample must be significant enough to make the probability of the type 1 error less than the value we choose for the level of significance. For this example, we choose 0.025 for the level of significance. So in order for us to be comfortable in rejecting the null hypothesis, the probability of making a type 1 error must be less than 2.5%. The alternate hypothesis we chose is the population mean is greater than 55. So we will be doing a right tail test. The 2.5% of the area is located in the right tail of the student's t distribution. Now we need to determine the value of t that has this area to its right. The t distribution table shows us that a one-tail area of 0.025 and a degrees of freedom of 14 returns a value of 2.145. This is a positive number because we are to the right of 0. This value, 2.145, is the critical t-score, and we will store it here. Next, we need to calculate the t-score of the value of the sample mean. Remember, we called this value the test t-score because it results from the test sample. Recall the equation to calculate this value. It is the population mean subtracted from the sample mean divided by the standard deviation of the sample divided by the square root of the sample size. This gives us a value of 1.453, and we'll store it here. At this value of t on the graph, we will place this vertical line. This clearly shows the area under the t distribution to the right of the test t-score is greater than 0.025, representing the level of significance. It follows then that the probability of making a type 1 error is greater than the level of significance, and we are not comfortable in rejecting the null hypothesis. So we do not reject the null hypothesis. The difference between the population mean and the sample mean is represented by this line. And given the criteria of the level of significance, the sample is not significant enough to reject the null hypothesis. If the sample had a mean that was larger, it would result in a t-score that would be correspondingly larger. If the sample mean is large enough to result in a test t-score that lies within the comfort zone, we would be comfortable in rejecting the null hypothesis. That is to say, the value of the sample mean is now significant enough to believe the population mean is larger than 55. Let's move the sample mean back to 57.25 and recall how we calculated the test t-score, and note the standard deviation of the sample is in the denominator, which implies that if the standard deviation of the sample were to be smaller, the magnitude of the test t-score would be larger, making the sample more significant, moving it into the comfort zone. Let's reset the standard deviation back to the original value. The test t-score is also a function of the sample size. Note that as the sample size increases, the magnitude of the test t-score increases and moves to the right, and eventually moves into the comfort zone, where we are comfortable in rejecting the null hypothesis. The sample mean, standard deviation, and sample size are all part of the calculation of the test t-score. Only when the area under the student's t-distribution to the right of the test t-score is less than the area specified by the level of significance do we reject the null hypothesis.